So hello again, grade 8. In this video we are going to complete the explanation of lesson 2 chapter 3. Now we have law of conservation. It states that when one form of energy is converted to another, no energy is destroyed in the process. So energy cannot be created or destroyed. This is very important. Whenever we are transforming a type of energy to another type, we won't lose any part of the energy. All of it is going to be transformed. None of it's going to be destroyed. We can never create or destroy energy. Conserving energy. It means saving energy or not wasting it. This means that we should not waste fuels such as gasoline, or our sources will be used up quickly. We have to try to conserve our energy. Law of conservation of energy. When one form of energy is converted to another, no energy is destroyed in the process. Energy cannot be created or destroyed, so the total amount of energy is the same before and after any process. All energy is accounted for. Conserving energy. When you hear or read about conserving energy, don't get confused with the law of conservation of energy. Conserving energy means saving energy or not wasting it. So this is conserving energy, and the other part is the law of conservation of energy. In science, energy is always conserved because its total quantity does not change. But we have to pay attention not to waste the energy. This is what they mean by conserving energy. Okay, energy conversion in a pendulum. So if you see the picture, I have 1, 2, 3, 4, 5 positions. On 1 and 5, I have the highest potential energy because the position is higher than the other positions, but I don't have a lot of speed. A continuous conversion between kinetic and potential energy takes place in the pendulum. At the highest point in its swing, the pendulum has only potential energy. It won't have a speed, it won't have a kinetic energy. But as it starts to swing downward, it speeds up and its potential energy changes to kinetic energy. Okay, review 2. State the law of conservation of energy in your own words. So the total energy before a process is the same as the total energy after. You can also say energy cannot be created nor destroyed. It can only be transformed. Review 3. Describe the energy conversions that occur when a ball is dropped and bounces back up. Why do you think the ball bounces a little lower each time? So, as it falls, potential energy changes to kinetic energy. As it bounces back up, kinetic energy is converted to potential energy. The ball does not bounce high because some energy escapes as thermal energy or sound when the ball hits the ground. Example problem conservation. Okay, we are going just to explain the photo that we have. In position 1, I have a speed, so I have kinetic energy, but I don't have potential energy because the person is on the ground. At position 2, I still have a certain speed, but I have a potential energy, so I assume that the speed is going to decrease because the sum of both should be conserved. And at 3, I don't have kinetic energy anymore because the potential energy is at its highest point because the person is on the top of this game, so he will have the highest potential energy, which means the kinetic energy should be equals to 0. He will have no speed in position 3. The sum is going to stay the same. Now when we come back, we are going to use numbers to solve these exercises. We will see them together and solve them together. For now, you have to understand that whenever I have a change in position, the potential energy might be changed into kinetic energy and vice versa. This is another example. So, in the beginning, I have kinetic energy equals to 0. I have the potential energy equals 50,000 joules. Then this girl is going down. Okay, now the kinetic energy becomes 20,000 joules because the girl has a speed. So I have kinetic energy. And the potential energy decreases from 50,000 to 30,000 because the height, the distance between the girl and the ground is getting smaller. And then at 30 meters, the kinetic energy is 35,000. As you can see, it's growing bigger, and the potential energy is decreasing 15,000. And then the girl goes up again. It will get the same kinetic energy because it's exactly on the same height as the second position. And finally, when she reaches the ground, the kinetic energy is the maximum, which is 50,000 joules, and the potential energy is 0. So at any position, if you add them both, you'll get the same answer. I can't create energy, I can only transform it. How energy transforms from one form to another. So energy cannot be created or destroyed, it just changes forms. Here, I have in this example, I have this cannon, chemical energy. It's changing to kinetic energy and then potential energy because it's going higher. At the top, I have less kinetic energy and more potential energy. And then when it goes down, it will be changed to heat, kinetic energy of molecules, because I will have a certain explosion. How energy transforms from one form to another. The roller coaster. As you can see, I have a roller coaster. In part A, I have potential energy. In part B, I have kinetic energy because the object's going down. The potential energy is decreasing. The speed is increasing, which means I will have kinetic energy. In C, it's a position in between both, so I will have potential and kinetic together. So as you can see, the sum is going to be always constant. The total energy is constant. Conservation of mechanical energy. This is also an example. So at the top, I have gravitational potential energy, which is the highest, which is 600,000 joules. The E here, they mean by E the mechanical energy, which is the sum of kinetic energy and potential energy, as we have seen in the previous lesson. And then this car is going down. So when it's going down, the potential energy is going down to 400,000, while the kinetic energy is going up to 200,000 because of the speed. If you pay attention, in the beginning, V0 equals to 0 meters per second, which means I don't have kinetic energy. And then it goes down more. The E, the mechanical energy, is always constant, 600,000 joules. But then the potential energy is 200,000 joules and the kinetic energy is 400,000 joules. And in the end, I don't have potential energy anymore because the object has reached the ground and the kinetic energy is at its maximum, which is 600,000 joules. The sum is always equal to 600,000 joules. Now, the work. The work is defined as a product of the force and the displacement of an object in the direction of the force. So whenever I'm moving something, I'm applying a force on a certain object, and this object is moving, I have a work. The work has a formula which is W equals F times S. Some books put S as D, which is distance. You can use both. So the matter is, you have to know it's the force in Newton and times the distance or the displacement or the changed distance between the initial position and the final position. The unit of work is also joule. Example. What is the work involved in moving a 10 kilogram shopping cart a distance of 10 meters to the right with a force of 12 Newton? So, if I don't have any frictional force, we will need to apply the formula. W equals F times D or times S. So F is the force in Newton, it's 12 Newton, times the distance, which is 10 meters. So 12 times 10 equals 120 joules. This is the work. Concept of work and energy. If little Nelly Newton lifts her 40 kilogram body a distance of 0.25 meters, What is the work done? The work is equal W equal F times S or times T. So F is the force. In this case, the force is the force needed to move a 40 kilogram body, which means I don't have a force here, I have a mass. But the mass is related to weight, which is the gravitational force. So M times J times S, 40 kilograms times 9.81, you can take it 10 because most of the exercise, especially for grade 8, you are allowed to take the G equals to 10 times 0.25 meters, and the answer is 100 joules. So the work done is 100 joules. And that's it. Thank you very much, grade 8.